Mr. McLeod here. I'm going to do really quickly is I'm going to show you how to use the moving man simulation. We talked about this a little bit, but I want to make sure that you have a thorough understanding. And you guys are currently in breakout rooms, so I'm literally doing this while you guys are working. So, that said, okay, the man, we can move him around as you can see, and as we move him, the graph moves forward, and if I let go, time goes by. So time is always moving forward no matter what, and time is the x-axis in all three of these graphs. I'm going to hit clear, I'm going to hit pause, and clear, and what I want you to do is I'm going to move him to, let's say, -6, I'm going to hit clear, and then I'm going to hit play, and I want you to look. His position doesn't change. It's stuck at -6, and as time goes by, he has no velocity, meaning his position isn't changing with time, and he has no acceleration, which means his velocity is not changing with time, meaning his speed isn't changing. Or another way, he's not speeding up or slowing down. So I'm going to hit clear again, and then what I'm going to do is I'm going to set him a speed of, let's say, 2. Okay, I'm going to hit play. And boom. Now you notice this little bump here at the beginning? You can ignore that. That's because he went from 0 to 2 all at once. In real life, this would be gradual. So let's ignore the graph before that bump happened. And let's just look at this piece right here. Well, he goes 2 meters per second pretty much constantly. And if we look at position, what that means is every second that goes by, every second in the x-axis that goes by, it goes up by 2 meters, right? And so the slope of the distance time graph, so distance divided by time, if we take this distance and we divided it by how long it's gone by, is actually equal to the velocity. So the slope of a distance time graph is a velocity graph, right? And if we were to now graph that velocity, whatever that is, well, we should just get a straight line because this is what is known as constant velocity, unchanging constant velocity. Okay, now, what is our acceleration? Well, constant velocity implies that we have no acceleration. It implies that velocity isn't changing. The definition of acceleration is increase or decrease in velocity. So if it's one number, it doesn't change. So this keeps track of change. Same way, if we took our velocity and we divided it by our time, or we took our rise, divided it by our run, right? The slope of this line gives us this number, okay? And of course, the slope is 0 because it's a straight flat line. So the acceleration is 0. Okay, let's try another example. Let's now say that if I give a position, or let's say I give an acceleration of 2. Let's go 1 meters per second squared. What this means is, and so I'm going to move him back. Let's pause. Let's move him all the way back to here and clear out all this data. There we go. Like I said, we're going to set this to 1. Okay. Now, if I set it to -1, he'd start moving in this direction. And if I set it to +1, he starts moving to the right in this direction. So I'm going to hit play, and what are we going to get? Well, we're going to get a changing velocity that changes per second, which gives us a constant acceleration, right? And if you watch the video, you see he's getting faster and faster and faster. And what happens is, that means his position is exponentially increasing. We get this curved line here, right? So if I took the slope of this line, this curve, we would get a function that's this diagonal line. And if I take the slope of this diagonal line, we get this. So this one's the slope of this one, and this one is the slope of this one. But what does it actually mean? Well, it means he's changing position rapidly. It means his speed is increasing in a very regular amount. So every second he's getting 2 meters or 1 meter per second faster. And his acceleration is constant. It is possible to have non-constant acceleration, but we'll talk about that later. And so that's what this means. And so one last thing I'm going to show you is we can actually have multiple things. So put them where I want them, hit pause, hit clear. And then what I can do is I can say, well, what if he stands still for, I don't know, a few seconds, checks his cell phone. I think there's a question that says that. Then he decides to move towards the house at 2 meters per second. Let's make sure he gets a little bit moving there. And then he realizes that he forgot something, so he kind of just slows down a little bit. So we're going to say negative 1 meters per second squared, meaning every second that goes, well, let's make it negative 0.5. I don't want him to slow down real fast. And he starts to slow down, and eventually you can see where he comes to a stop, turns around, and starts moving the other direction. Because his acceleration ate away at his velocity until it reached 0, and then it started going in the opposite direction. Anyway, that's the video. I wanted to make sure you knew how to use this, and I'll let you guys go.